We're going to talk about normal distributions, and all the normal distributions can be modeled by this bell-shaped curve called a normal curve. It is symmetric around the mean. Sometimes you're going to see the mean expressed as this symbol here, or you can see the mean expressed as this. So I just want you to recognize that if you see either one of those, that is the mean. And now this symbol here is the standard deviation. And so, for instance, we're taking the mean plus standard deviation, the mean plus 2 times standard deviation, and so on. All the bell curves are going to have the percents on each side be exactly the same. So 34% here and there, 13.5 on both sides, 2.35 on both sides, and 0.15 on both sides. A normal distribution has a mean of that x symbol and standard deviation with the symbol. For a randomly selected x value from the distribution, find the probability between the mean minus the 2 deviations and then just the mean. And so when we do this, we're looking at the mean minus 2 distributions. So we're talking about the mean, which would be down here. This is the mean minus the distribution, or the deviation, I mean. And this is the mean minus 2 deviation. So we're looking at 13.6 on this graph. And I think on the other one it said 13.5, which is fine. Doesn't really matter. We're going to change that to a decimal. So you would just move it over twice. And then we're talking about the 34%. So 0.34. And if you add those two together, 0.475. So that is the percentage that you would get inside the mean all the way to 2 minus 2 deviations. This one we're talking about more than the x minus the deviation. So the mean minus deviation, that would be right here. And we're talking about more than that. So it would be from this line all the way over. But if you notice this symbol here, it has to stop at the mean plus 1 deviation, which would be right here. So we're actually going to shade all over in here. And if you combine those two, we have 0.34, because it's 34% here, and 0.34, 34% in that one as well. And you add them together, and you get that as your answer. All right, we're going to give the percent of the area under the normal curve represented by the shaded region. This is easy. All you have to do is look at what this shaded region has. There's 13.6 here, and there's 2.2 there. So what we have to do is add the two together. Sorry, it should be a 6. And when we add those two together, all we have is 15.8%. So that is the region under the shaded part. A normal distribution has a mean of 33. So already I'm just going to label this 33 because that is what our mean is. And then a standard deviation of 4. So if I wanted to calculate this out, we're going to follow the symbols, what they say. We have 33 plus 1 deviation. The deviation is 4. Then we have 33 plus 2 times 4. And I'm running out of room. So, and then we have the 33 plus 3 times 4. And on this side, we have the opposite. We have 33 minus 4, 33 minus 2 times 4, and 33 minus 3 times 4. Okay, so the middle stays the same. 33 minus 4 is, or I'm sorry, this should be plus. 33 plus 4 is 37. 33 plus 8 is 41. Okay, so we're looking at this line. And over here we have 33 plus 12, and that is 45. Okay, so we're talking about there. Okay, on this side we have 33 minus 4, and that is 29. So that's that line. This line would be 33 minus 8, which is 25. And this line is 33 minus 12, and that is 21. Okay, so all I did was fill in the numbers they gave me, and now they want us to find the probability between this interval, so 21 and 41. So we're looking at from 21 all the way to 41. And you can shade it if you'd like. Okay, so all we have to do now is figure out the percentages. And those remain the same. Okay, we have 13.6 here percent. We have 34, 34, 13.6, and the other one is 2.35.